Welcome to MAEnow. I am MAEcy. Join me while I check out research being done by Professor Avedisian's undergraduate student.
Hi, my name is Eric Ching. Thanks for having me, MAEcy.
Where are you from?
So I'm from Edison, New Jersey, which was named in honor of the famous Thomas Edison. And it's actually home to his main research lab in Menlo Park. I decided to study mechanical engineering at Cornell because, well, first, it's a great engineering school, and it's also a very big school, which means there's lots of people to meet and a lot of great resources. And mechanical engineering, it's a very broad discipline, which means it's heavily involved in almost every technology, whether it's like cars, airplanes, computers, medical technologies. It's basically everywhere.
How did you get interested in your research?
I wanted to get some hands-on experience, and I was also interested in energy transfer and thermal sciences, and I saw that Professor Avedisian shared similar interests with me. So I talked to him and joined his lab, and I've stuck with it ever since.
Please share with us about your research.
So welcome to the Thermal Sciences Laboratory. Sorry about the background noise. This is where we actually do experiments. This is where everything that we're interested in occurs on this little chip. This whole thing is what we call a dual line package, and in the middle is a chip that contains 8 thin film platinum microheaters. They're really tiny, and you can only really see them using a microscope. What we use these heaters for is to achieve microscale boiling in a variety of liquids, such as water, ethanol, methanol, to heat the liquids. They reach temperatures well above their normal boiling points. For example, water can reach up to 300 degrees Celsius compared to its normal 100 degrees Celsius boiling point, which is pretty amazing. And that's because we heat it at extremely high heating rates using the extremely small scale thin film heaters. And since the boiling occurs on a very small scale, we use this little guy, it's called an oscilloscope, to help visualize what's happening. And let me show you guys how we do the experiments. So first we put the chip, the heaters, in a circuit known as it's a Wheatstone bridge circuit, and we pulse the heater with really short pulses on the range of like 500 nanoseconds to 10 microseconds long. What the oscilloscope shows is the voltage of the heater as a function of time, and we record the data, and later we can use a bunch of equations. We can convert it to temperature versus time, and that's how we record the temperature of whatever liquid is being heated. What's being shown on the screen is the output voltage versus time, and as we increase the input voltage, you can see the output voltage begin to increase. That means, and the output voltage, it's essentially proportional to the temperature. So you can imagine as the output voltage is increasing, like it is right now, then the temperature of the liquid is also increasing. Eventually, we'll see an inflection point, as you can see toward the end of the pulse. And what that means is that that's when the microscale boiling has occurred, and these really small scale bubbles begin to form and cover the heater. So one of the reasons this physical process is important is that when the microscale bubbles they form in the liquid, they can exert like a piston effect, where they push the surrounding liquid through a small channel, for example. And this has a lot of applications, actually. For example, small scale drug delivery, bubble pumps, anything that relies on small scale fluid transport. One of the biggest applications is thermal inkjet printing, which relies on a very similar process to transfer ink through the printer. And in our lab, we've actually come up with a new design for the heaters, which dramatically reduces the amount of power needed to achieve the microscale boiling. So we think our experiment, our research has a lot of promise when it comes to battery operated printers. which would be a lot more portable than the traditional printers. Thanks for joining us in our lab, and I'll meet you back at the studio.
What would you enjoy doing after you graduate?
After I graduate from Cornell, I'll be attending graduate school, also for mechanical engineering, and I'll be probably specializing in fluid dynamics, so that in the future, I'll be able to pursue even more research, maybe in a lab or in academia.
What do you do for fun outside of academics?
Free time outside of academics, I like to just hang out with friends, eat, play sports, and from time to time I'll go snowboarding. There's actually a couple places to go snowboarding nearby. Do you want to go sometime, MAEcy?
Shredding the gnar.
Well, I hope you enjoyed learning about the kind of research I do here. Thanks for having me.
Wow. I like to learn new things, and that my friend was exciting. Thank you for being part of MAEnow.